Hi, my name is Joe.
I'm Brandon.
And I'm Donnie. We're the team behind QLegance.
GraphQL is an innovative query language that introduces a new form of server-side data resolution. RESTful thinking traditionally contains multiple server endpoints that can lead to performance issues as the application grows in complexity. One of the many benefits of GraphQL is that it reduces these multiple server endpoints down to one. Queries to this endpoint are resolved against a strongly typed GraphQL schema. The server then responds with the exact information that you requested, never over or under fetching. In addition, queries can be aggregated to reduce multiple requests down to a single request. That's why large data-driven companies such as Facebook choose to utilize the power of GraphQL. However, the developer must now spend extra time managing these new GraphQL queries. In the absence of a pattern to oversee queries, we developed QLegance.
QLegance is a client-side solution for GraphQL querying. Our library handles both data fetching and mutation. Instead of having to wrap an HTTP request around each query, the developer has access to the equivalent request through our dynamically built methods. We utilize these methods with QLegance components in the QL object interface. Next, we'll take a look at how all this is done, as well as our caching feature, which eliminates redundant requests to the server.
So your QLegance application first starts by sending an introspection query to your GraphQL server. It then examines the schema that was defined in the backend and returns all types of fields back to our library as a JSON object. Our library then parses through this JSON object using a method constructor algorithm. This algorithm follows a linked list pattern to dynamically build both nested and non-nested field methods for the developer to call on in their application.
So QLegance works with the features your web application already has, as to not eliminate projects by design decisions. Our library targets unique HTML attributes which the developer will define in the document. So for instance, we have QL list. So here's what your HTML will potentially look like. Once your QLegance component is defined and within its tags, the component will announce what information it actually needs. This is done with the QL field attribute. And the use of a QL list, this HTML template will replicate for the number of data entries returned in the request. This pattern designated by components defining the information they need will actually auto-populate the QLegance application. So here's an example. We have a sample website set up, and this is going to show some of the projects by the engineers here tonight. Now, the output of this website itself is not very standout. With the simple QLegance library import, this page is displayed with intuitive population, defined solely with the HTML components of QLegance. Lastly, we have QLegance's network prioritization with caching.
Our client-side cache reduces the need to make repeated calls for the same information. In the case where the data is not in the cache, a diffing algorithm is implemented between the request and the cache data to form a new query for the missing information. The return JSON object is then flattened and dipped again with the cache, so it knows exactly where to attach this new data before being returned back to the client.
With these features, QLegance makes managing GraphQL queries in your client-side environment easier and more efficient. We hope you try it out on your next GraphQL project. You can find us on GitHub, NPM, and our website, QLegance.com. Thank you.